Bismillahirrahmanirrahim. Ribonucleotide reductase converts the ribonucleotides to their deoxy forms for their utilization in the DNA synthesis. The substrates for the ribonucleotide reductase include adenine and guanine from amongst the purines and cytosine and uracil from amongst the pyrimidines. So, ribonucleotide reductase is a dimer. It consists of two subunits, alpha, also called the R1 and the R2 subunit. And here you can see there are some sulfhydryl groups shown in black, and these are going to act as the donors of the hydrogen atoms for the reduction of the hydroxyl group present on the 2' position of the sugar moiety attached to the ribonucleotides. Now, the alpha 1 subunit contains two allosteric sites. One is the substrate specificity site, and the other is the activity site. Now, the molecule which binds to the substrate specificity site decides that which ribonucleotide is going to be reduced. Now, the molecule which may be present at the substrate specificity site is in the form of triphosphate nucleoside triphosphates, and whereas the activity site, if ATP binds, this enzyme is going to be active, and if a deoxy form of ATP binds, it is going to be inhibited. So just to show the mechanism of action of this enzyme, here the example of ADP is shown. Here you can appreciate there are sulfhydryl groups present on the R1 subunit. The catalytic activity resides in the beta or R2 subunit, whereas that which molecule is to be converted to its deoxy form depends on the molecule sitting on the substrate specificity site. So here we can see that there are the donors of the hydrogen atoms in sulfhydryl groups. So the hydroxyl group on the 2' position is removed and released as water. The 2' position of the sugar moiety is reduced, and in this process the sulfhydryl groups were oxidized, which are going to be reduced by the thioredoxin, and during this process the thioredoxin becomes oxidized, which is going to be reduced by the NADPH coming from the HMP shunt. So this cycle continues on, and you can appreciate that the deoxy form of the nucleotide is generated. Now we'll take up one by one the regulation depending on the molecule occupying the substrate specificity site. This is a bit complex. So first of all, if ATP is sitting at the substrate specificity site, ATP is going to decide that which nucleotide diphosphates are going to be reduced. In presence of ATP, pyrimidine nucleotide diphosphates are going to be converted to their deoxy forms, and cytosine and uracil are going to be the substrates, whereas TP is going to accumulate. So first of all, we'll take the example of uridine diphosphate. So there is ATP at the substrate specificity site, and it is just that it is sitting in the driving seat, and it is dictating which substrate is going to be reduced. So UDP is going to be reduced. The sulfhydryl groups are going to provide the hydrogen atoms needed for reduction. Hydroxyl group on the 2' position is released as water, and the other hydrogen atom has reduced the 2' position, and now it is converted to its deoxy form. Now this oxidized form of the enzyme is reduced by the hydrogens provided by the thioredoxin, which is the coenzyme, and thioredoxin becomes reduced. Becomes oxidized, and its reduced form is replenished by NADPH from the HMP shunt. So here you can see that now UDP is converted to deoxy UDP. Now if it loses one phosphate, it is going to be converted to deoxy UMP. The significance of DUMP is that DUMP can acquire a methyl group from tetrahydrofolate, and if it acquires a methyl group, now it is going to be converted to thymidine. So DTMP is generated. DTMP, if it acquires phosphate in the presence of kinases, it is going to be converted to DTDP. And DTDP can acquire one more phosphate, and then it becomes DTTP. So DTTP is going to accumulate. So this is the reason that why among the substrates there was no thymidine nucleotide, because it is generated from UDP. Next, we are going to consider the example of CDP, and CDP can also lead to the generation of deoxy T. So here is the CDP. Again, the sulfhydryl groups are going to act as the donors of the hydrogen atoms. Water is going to be released, the sugar moiety is reduced, and this reduced form of the enzyme is going to be, oxidized form of the enzyme is going to be reduced by the hydrogen atoms provided by the coenzyme thioredoxin, which becomes oxidized, and reduced form of the thioredoxin is going to be regenerated by NADPH. So this cycle continues and DCDP is produced. Now DCDP, if it loses this nitrogen at the top and this nitrogen is replaced by the oxygen, it is going to be converted to DUDP, and if it loses one phosphate, it is going to be converted to DUMP. Now again, this is the significant molecule which can acquire a methyl group, and after acquiring the methyl group, it is converted to DTMP. DTMP, after acquiring phosphates, can be converted to DTDP and DTTP. So DTTP is going to accumulate. Now when DTTP, it is going to displace the ATP at the substrate specificity site. So when DTTP is sitting at the substrate specificity site, now it is going to decide that which substrate is now going to be converted to its deoxy form, and in presence of DTTP, GDP is going to be converted to deoxy GDP. So this is the GDP. You can appreciate it is an oxypurine with the oxygen group at its top. So again, the sulfhydryl groups are providing the hydrogen atoms. Hydroxyl group is released as water. The sugar moiety is reduced, and the oxidized form of the ribonucleotide reductase is again reduced by the thioredoxin, and oxidized forms of the thioredoxin is reduced by NADPH, and there is the formation of deoxy form of the GDP. So DGDP is going to now accumulate, because this cycle can go on, and when DGDP accumulates, it is going to displace the DTTP at the substrate specificity site, and when DGDP is sitting at the substrate specificity site, now it will prefer that ADP is converted to DATP. So here you can see that DTTP is going to be replaced by the DGDP, and now DGDP is going to lead to the conversion of DATP to its deoxy form. Again, these sulfhydryl groups provide the hydrogen atoms. The sugar moiety is reduced, and the oxidized form of the enzyme is reduced by thioredoxin, and the oxidized form of the thioredoxin is reduced by NADPH. and this cycle continues, and DATP can acquire phosphate, and then it's converted to DATP. And DATP, when present, it is going to now displace the ATP present at the activity site. So ATP is present at the activity site is going to be replaced by DATP, and DATP at the activity site inhibits the enzyme. So here you can see that DATP is going to occupy the activity site, and now all the deoxy forms of the nucleotides have been generated. As you see that DCTP has been formed, TTP has been formed, DGTP has been formed, and DATP has been formed. So now this machinery is going to be inhibited in the presence of DATP. So the thing to remember is that the substrates for the ribonucleotide reductase are the ribonucleoside diphosphates. Only ribonucleoside diphosphates are the substrates, and these are later converted to their triphosphate forms by acquiring phosphates in the presence of kinases. Whereas the molecule which sits at the substrate specificity site and dictates that which substrate is going to be converted to its deoxy form is always in the form of triphosphate. And finally, first of all, ATP sits on the substrate specificity site, and there is the formation of DTTP. And when DTTP accumulates, it is going to displace ATP, and DTTP leads to the conversion of GDP to DGTP. When DGTP accumulates, it is going to displace TTP from the substrate activity site, and it is going to lead to the conversion of ATP to DATP, ADP to DATP, and DATP is going to inhibit the enzyme. So that's all. That now we have seen that all the deoxy ribonucleotides have been formed, and DNA synthesis can take place now. The lead area